Hi physics students, so we are going to go over warm-up 7-4B, which is a review of what we covered in our Coulomb's Law lab and the homework on the concept builder, as well as a introduction to electric fields. So in this first problem, we've got a positive and a negative charge, which we know opposites attract. Now the force between them is 25 newtons, and it says that the proton has doubled its charge and the distance between them has tripled. So when we are working with a problem like this, we're focused on proportions between the charge and force as well as the distance and force. So if you remember from our Coulomb's Law lab, charge, which is represented by Q, is directly proportional to force, and distance is inversely proportional to force, but inverse by a factor of the distance squared. So it's an inverse squared proportion. So this is our proportion when we are working with how charge and distance affect the force. So we start off with 25 newtons and know that the charge has doubled. Because they are direct proportions of each other, if the charge doubles, then the force also doubles. So we're going to end up with 50 newtons after doubling the charge. The next step is to understand that the distance has tripled. And if you increase distance, you're going to decrease the force by a factor squared. So the next step is I'm going to take this new value of 50 and divide it by triple the distance, 3 times the distance, and square that. So it's really 50 divided by 9, which gives me a value of 5.5 or 5.6 newtons, around there. So that's my answer for proportions, very similar to the concept builder homework on Coulomb's Law that you did over the weekend. Now, this next problem is an introduction to electric fields, but before we talk about electric fields, I just want you to think about how charges interact. Now, we've only talked about 2 charges interacting with each other, so if I bring in this big negative charge and this big positive charge into a field, we now have 3 charges interacting. I want you to think about this negative and this positive charge as fixed charges, so they cannot move, and the small positive charge as a test charge, and we call test charges that are free to move based on the forces they experience with the charges around them. So before we think about how this positive charge is affected by both the negative and the positive, I just want you to think about how it's affected by this big positive charge first, because distance is important, and the closer it is to the positive charge, the more force it's going to feel from that positive charge versus this negative charge that's further away, and so the force is not as strong. Well, we remember that positive charges repel each other, like charges repel each other. So this positive charge is going to shoot out as far away from that big positive charge as fast as it can. As it's moving away, the distance is increasing, and therefore the force is decreasing, again, by a factor squared. And so as it moves away, we can now determine how this negative charge is going to affect it. And we know that positive and negative charges attract. So as it moves upward, it is then going to feel this attraction toward this negative charge. So by understanding the path, and I'm going to use a different color here, the path of this positive charge, it's going to go up away from the positive and down into the negative. It's going to create this curve. Now, this is basically what creates the electric field of charged objects. So all the electric field arrows are going to point away from the positive, and into the negative. It doesn't matter where you are in the electric field, it's always going to have that same pattern. So you're always going to think about how a positive charge would move when it is in the vicinity of a charged object. So an electric field is a set of arrows. No matter where you put this positive charge, what direction is that positive test charge going to move? Always out of the positive and into the negative. So as you work with your electric field tasks today, you should see a similar pattern of arrows pointing out of the positive and into the negative. All right, go ahead and work on the assignments for today. If you have any questions, feel free to contact me, and we will review some of this stuff next class. Good luck.